All right, so we're gonna kind of wrap up our chemistry unit. We're gonna finish up with talking about acids and bases. Already had some experience with acids and bases in the labs. We've seen hydrochloric acid, we've seen sodium hydroxide, and we've seen some indicators. So now let's talk a little bit more about what each of these kind of means. So acids and bases are some very common compounds. Got lots of them around your house, probably even eaten some of them today. So we classify acids and bases based on their chemical composition. Acids and bases can be extremely corrosive. That's why you never, ever touch them, especially in the chemistry lab. So don't use touch to figure out if something is an acid or if it's a base. Said some acids and bases are commonly found in food, but in a chemistry lab, concentrations are so extreme that they are unsafe to handle directly. Just have to be very careful of them. They can cause some pretty severe chemical burns. So we measure acids and bases using this thing called the pH scale. So the pH scale runs from 0 to 14. So everything between 0 and 7 is acidic. Anything from 7.1 to 14 is basic. If our pH is at 7, it means we are dealing with a neutral solution. It's neither acidic or basic. So below 7, acidic. Above 7, it's basic. If it's at 7, it is neutral. And the pH scale is not a linear scale. It's actually a logarithmic scale. This means that every step on the pH scale doesn't mean you're doubling the strength of the acid. It means you're increasing the strength by 10 times. So if you go from a pH of 4 to a pH of 5, 4 is 10 times as acidic as a pH of 5. If you go from a pH of 3 to a pH of 6, so 3 to 4, multiply that by 10, 4 to 5, multiply that by 10 again, 5 to 6, multiply that by 10 for the third time, end up with an increase in 1,000 times. So there are other scales you've probably interacted with that are also logarithmic. Sound is one of them. Decibels are on a logarithmic scale. Every step is an increase of 10. pH is just like that. Do have a few examples down there of some common kind of pH conditions for different substances. So your stomach acid works at a pH of 2. With that low pH, it can work to break down proteins. Tomato juice is also slightly acidic. On average, they've got a pH of 4. If you've ever cooked with cast iron and you have tomatoes on there, tomato juice can actually break down the cast frying pan. Water has a pH of 7, or pure water has a pH of 7. In reality, water is slightly acidic because we have carbon dioxide in the air, and carbon dioxide reacts with water to form a very, very weak acid. On our basic side, most soaps and cleaners are more basic. So hand soap can have a pH of around 10. If you've ever done any cleaning with ammonia or bleach, those are both very basic. Also extremely corrosive. You don't want to ever touch those chemicals. So as you saw with our kind of solutions, you can't really tell pH just by looking at it. Many substances with a pH can be colorless or clear. You can't tell it apart just by looking at it. So instead, we can use other chemicals that are called indicators to kind of narrow down a pH range. So some chemicals can be added to a compound. They will change color if it's above or below a certain pH. You can also use the electrical conductivity of a solution to figure out if it is acidic or basic. So these indicators are probably something you'll want to look at for your mystery compound lab. So our indicators can kind of change color based on what type of solution we put it into, whether it's acidic or basic. One really common indicator is called litmus paper. Got a picture of it up on the top right. Got two types of litmus paper, either blue litmus paper or a red litmus paper. Or if we have some blue litmus paper and we stick it in a base, nothing's going to happen. But if we take some blue litmus paper and stick it inside of an acid, it's going to turn red. If we have some red litmus paper and we stick it in acid, we won't really see any color change. But if we take that red litmus paper and stick it inside of a base, then it will go blue. So if we see our litmus paper turn blue, it's basic. If we see it turn red, it is acidic. Which means from there, blue, we know our pH is above 7. Red, our pH is below 7. So it's good to tell you whether or not it's acidic or basic, but it doesn't really narrow down a more specific color range. A kind of more helpful tool is a thing called universal indicator. So a universal indicator can turn colors at different pHs. So a universal indicator can either be in a liquid form or it can be on a kind of paper strip. So if it's on a paper strip, you just kind of put this strip of paper in your solution and you'll see a color change. If you're dealing with a liquid universal indicator, kind of see a row of colors like we have in that row of beakers on that bottom picture. So you know our solution is more acidic on the left side and it's more basic on the right side. We'll talk about this shortly, but acids and bases can carry an electric charge. We can use a pH meter to actually measure how much electric currents can move through that solution. Do have other types of indicators that can change colors at different pH values. So they're kind of more helpful in a narrower range than just our litmus paper. If we look at our bromothymol blue, it starts out if it being really blue in a basic solution, it turns yellow in an acidic solution. So kind of between a pH of 6.5 to 7.5, we see a kind of greenish color change. So we've got a more narrow pH range there. Phenolphthalein, it's white if the pH is, or it's colorless if the pH is roughly below 8. And it starts to turn more pink as you hit that 8 and above pH range. You can also make indicators from natural sources. So many fruits and berries can kind of juice them as an indicator. One very useful fruit source or a vegetable source for indicators is in the form of red cabbage. So if you take a red cabbage and juice it, you can use the juice as a pH indicator, and you'll kind of get a color range similar to the universal indicator. So cabbage juice is kind of a light red in acidic solutions. It's a deep purple in basic solutions, and you get a range of colors in between. So this might be one thing you should look up for your mystery compound lab. You might want to look at making this indicator. So on page 135, got a chart, kind of lists a few different indicators and some kind of useful color ranges and kind of what colors you'll expect at different pHs. So I'd suggest kind of pausing here, take a few minutes, fill out this pH scale in your notes, and I would suggest coloring in your different pHs. Will help you to identify where you get your color changes and what your useful ranges are for each indicator. So on your next page, got a few different substances. Take a few minutes, kind of figure out what the pH values of these substances are. This table will help you. Got most of those substances listed there and their common pH values. Figure out if it's an acid or a base, and you'll just figure out what color you'll expect it to change with a given indicator. So take a few minutes, try and work through these questions, and identify whether they're acids or bases and what color of indicator you'd expect.